Okay, so a few nuggets about Pinterest engineering. So we have over 1,600 full-time engineers. About 10% of those in data engineering. We have about 170 engineers. We have another about 50 that are contractors. To give you an idea of the scale, we do 400 million machine learning inferences, that's in serving, per second. We log about 60 million events per second. And we have about an exabyte of data, that's about 1,000 petabytes. So quite large scale. So today I'm going to talk about two different areas and two different solutions. One is to improve analytical productivity, which is needed not just for data scientists and product analysts, but for engineers. At Pinterest, everyone operates with data. Everyone knows data really well and uses data to experiment, and that's how we decide what to push out into production. We actually run about 1,000 experiments in parallel at any point in time. And so everyone is doing data analysis all the time. So it's important to improve productivity there. Also going to talk about improving developer productivity as well, give you some ideas how we did that. And one of the ways that we measure productivity is not just through the number of commits per month, but we also look at NPS, our Net Promoter Score, on what the developer satisfaction is. When I started at Pinterest almost 5 years ago, our developer satisfaction score was -5. So just to give you an idea what NPS is, when your NPS score is -100, that means everyone hates your product. When it's +100, everyone loves your product. And so we were at -5. And now we're at +65. Most companies are around about between 20 and 40. But our developer productivity satisfaction is really high now. So I'll give you some insights how we've done that. Okay, so first off, solving our analytical productivity. And so what we do in any case when we're trying to figure out how to improve productivity, first of all, we need to understand our internal customers. And so we ask them, what are they trying to do each day? And what work do they need to do in order to complete these tasks? And so for analytics, we found that we needed some capabilities within our analytical user interfaces and some other capabilities to be able to join data easier, to be able to add data easier. The clicker's not working. So we need to improve the user interface. We also need to improve the quality of the data. At Pinterest, we had over 300,000 data sets. And so it was very hard to figure out which data set to use and what the quality of that data was as well, and actually have owners for that data. And then the third challenge we had was knowledge. We have lots of different silos. So we have our shopping, we have ads, we have our core organic products, we have growth. There's sales, finance, there's many different silos, and the knowledge was not shared. So how do we actually share that knowledge? Okay, so we had lots of obstacles to improving our productivity for analytics. For the tables we got less than 24% of those were documented. 53% didn't have an owner. Less than 1% of queries used a tier 1 table. And so we were in a pretty bad state, and this is like 2 years ago now. So lack of trust in the data. People would spend days and days trying to figure out which data was correct and compare. They wouldn't be able to find the data sets that they needed. It would take them a long time. And essentially, we had a whole bunch of obstacles that we needed to overcome and to try and speed up this whole process. Okay, so when we talk to the developers and the analysts and the data scientists, machine learning engineers, we ask them how do they spend their time. We actually measured how much time is spent in each phase of solving a problem. And so, first of all, it's actually trying to understand the problem. You can't really reduce the time for that. Then people spent a huge amount of time figuring out which data set to use, trying to massage the data into the right form so that it could actually be used, and then figuring out the insights into the data. And we found that we spent about 40% of our time, the clicker's not working, about 40% of our time just discovering data and getting the right data before we can actually do anything. We felt we could reduce that way down so that discovery would be really easy. We'd have trustworthy data that is validated that people could use straight out of the box. So we were going from having data silos, where there was no standardization across the data. There was very little data reuse. People would just copy the data and then use it for their own purposes. The quality was low because we didn't have ownership. We didn't actually measure the quality. And so it was very inefficient, and an exabyte of data. But on the other end of the spectrum is creating like a centralized governance where there's lots of red tape, where you have to go to a governance team to ask if you can add some data. And we really didn't want that. We don't want any red tape. Within Pinterest, the idea is minimize red tape and let developers, engineers run as fast as they want to run with no obstacles or barriers. So we were right here on the left-hand side. And where we wanted to get to was somewhere in the middle where we had some lightweight governance and good quality data and trustworthy data, and to bring the data silos together. So what we did was we built a data mesh. I'm not going to spend time describing or telling you what a data mesh is. I highly recommend you go and look it up if you want to go and figure out what the solution is. But at a high level, there are 4 main principles for a data mesh. One is that it's domain-oriented. So the people that understand the data the most are in the domain itself. So for example, in ads, they understand the revenue and click-through rate. In growth, they understand how to grow the usage of their product, and they understand all the metrics around that. And so the best place to own the data is in each domain. We also wanted to have data as a product. So highly validated, trustworthy data that you can access through APIs. There needed to be some federated governance, because when we do experiments in production, and we're doing 1,000 experiments in parallel, we're measuring about 1,000 metrics at the same time, where we need to look at what's the impact on engagement, what's the impact on ad revenue, as well as a whole variety of other things. And so we needed some lightweight governance across that, and be able to join the data across these different domains. We also wanted self-serve platforms so that developers could quickly go and get the answers that they wanted and produce the insights they wanted and discover the data without having to even go and talk to someone else. Okay, so the main places that we invested, there are like 4 major areas here, and you can see at the top there, when you're dealing with data, it's going from logging in your serving systems to collecting that data, putting it into a data warehouse or data mesh, and then doing some business intelligence on that and some analytics as well. And so there were 3 major areas. One was creating a self-serve platform that everyone could use, and it required having a metadata platform where we would have the schemas for all the trustworthy data that you could go and access and see what the metadata was, what even tables were there, and some analytical tools. One of the tools we actually created and we open sourced a couple of years ago is called QueryBook. And QueryBook enables you to write queries, share queries with other people, and basically riff on queries and make you far more productive at creating SQL across a big data store. And we wanted to adopt Superset, which is another open source tool for analytics UI. For the metadata, we used a data hub that LinkedIn open sourced, and so we've built on top of that. So everything that we've got is actually open source, and you can use it too. For governance, we really wanted just lightweight governance, but we had to have some standards. We needed to have some standards across what the fields were, what the metrics were, and how they were computed, and what the taxonomies were, and to be able to have some standards around what should be the tier 1 tables. And for that, we created a group of data stewards. So a data steward is someone that understands the domain extremely well. They're usually a data scientist or a product analyst. And we have a data steward in each domain, at least one, but one at a minimum. And then they come together to do some lightweight governance to make sure the data can be joined across the whole company. And then last but not least is Table standardization. We had 300,000 tables, actually more. It kept on, it was like Moore's law. It grew, doubled in size every 18 months, and we're constantly trying to chop down the number of tables. And so we analyze these tables to see which tables are used the most frequently, so that then we can standardize. We can make the data in those tables owned, can make it trustworthy, and make those tables highly reliable, so they're always produced on time. And the idea really, or the goal was, to have the minimum number of tables that would get us to at least 80% of queries. So it's taken us a couple of years to get to where we are so far. We started building the metadata platform and the analytics tooling, and then we started standardizing the fields, the metrics. And you can see on the left-hand side, there's the number of, in the blue line is the number of tables that we standardized as tier 1. And then on the right is the number of queries that were queried against those tables. And you can see that we're up to over 40% of queries against about 170 tables there. We're going to aim to get to up to 80%. And one of the ways to do that is to actually help users figure out which tables to use so they're querying the right tables. So we have a number of ways to do that to optimize our table searches. So here's a demo of QueryBook. So if you wanted to find what table and field shall I use to find the top 50 retailers in the US, you could type in revenue. It will give you a list of tables. You could type in retailer, and it would point which table you should use. It will then show you which columns to use and have descriptions around all of these. And then after that, you can go and create a query. So we're kind of moving from having the 300,000 tables that are tier 3 that we actually want to get rid of on a regular basis. And so we have a retention of about 90 days for that. And we're taking them up to tier 2, where there's a bit more documentation, and they're production grade, so the production data that we do want to do some analysis on. But ultimately, we want to get tables up to tier 1, where they have owners, that you know who to contact, they have SLAs, the documentation is really good. And so that's what we're doing. Okay, so our data stewards, who are these product analysts, data scientists, who own each domain and what the schema for that domain looks like. So they're really, they have to guarantee the trust of, what are the tier 1 tables, and they talk with their data producers. These are the engineers that are actually logging the data to make sure that those, the right data is being logged. We've actually been using large language models to automatically document our tables. So incredibly, LLMs give better documentation on tables than a human could do most of the time. But we go and verify that the documentation is correct and just tick that off. And the other thing that data stewards have been doing, going through all the fields, all the major fields, so like about 1,500 fields they've standardized. They've also standardized many of the metric definitions. So then there's one common, when you talk about metric, there's one common way to define that metric across the whole of Pinterest. Like I mentioned, we built this data catalog on top of LinkedIn's Data Hub, and it have added some extra functionality that will open source for that. And so we've put all the documentation into that, our schemas, our metrics into that. We have some policies around retention. We have retention on all data now. And this is to also improve the discoverability of the data. And so there's a little demo here of what the Data Hub looks like and how you can actually go and add documentation to a table. We've also added some AI-assisted tooling. So one here is doing text to SQL. So we actually say, like, I want to have want to know the top 50 retailers in the US. It will figure out automatically which table to go to and then automatically generate the SQL. It's about 95% accurate. And if you want to go and edit the SQL, it will automatically fix the SQL for you. And it will automatically generate a title and description of what's being produced. And it will also help us on our table searches as well. We've been using Superset. We now have 1,000 monthly active users on Superset. So that's about a quarter of Pinterest is using it on a very regular basis. And that just enables us to create charts very easily, drag and drop, don't need to code. and you can also create some SQL to create a chart there as well. Okay, so we've had some great user feedback on this. Many people are much happier now. They can go much faster. And so that's one way to increase your productivity 2x. So next up, I'm going to go and talk about for developers and how do we actually improve coding velocity. So using generative AI, so there's a study that GitHub did with I think, Microsoft and some academia. And they thought, or they figured out that they could actually improve productivity by 2x by using GitHub Copilot. We also did proof of concept, and I'll show you the results in the next slide. But first of all, there's a couple of generative AI tools that I highly recommend. If you're not using them today, you should definitely start using them. One is GitHub Copilot, and this has got IDE extensions to be able to generate code for you based on a description. It can also generate unit tests and improve your testing. And it can explain code as well, so it actually makes you far more productive. And in ChatGPT, we've been using ChatGPT for a variety of use cases, writing documentations for us, doing Slack Q&A, so you can actually ask a question, it will automatically generate the answer. And also for migrating code. So some code we've got in cascading, we've got like over 500 jobs in cascading, which is deprecated. We need to move that over to Spark, and it's able to actually give pretty good results. Not perfect, but it gives us a good start for doing a migration. Okay, so I mentioned that we did a proof of concept for Copilot with Copilot from GitHub. We had 200 engineers that we did this proof of concept for. We got different results from GitHub, and I thought it'd be interesting for you to see what the results were. When we measure the commit rate, so this is number of commits per month per engineer, if you put them into different cohorts, so the ones that are not committing as much code, we found that we could make them between 50 and 100% more productive than before. When we looked at our really more senior engineers that were committing a lot of code on a regular basis, they became about 40% more productive. And then the ones in the middle actually didn't become more productive at all. Now, we have some ideas around that. Maybe the code that's being created by Copilot requires so much time to go and analyze and figure out, to actually use and then edit, and that might be taking it. But the overall developer sentiment was really high across the board with using Copilot, and we had some really fantastic quotes there, and the NPS score is around 70, 75. So people, engineers really did love it. So some other productivity use cases that we've been using large language models for that you could too. So I mentioned Slack support. What this has really encouraged us to do is improve our internal documentation. So before, every team would have their own Slack channel, so you would ping that team if you had a question. Now, with better documentation, we have automated Q&A within Slack. So we'll send the documentation that we have into GPT-4, and then it will generate the answer. Then the user can say whether the answer is good or not. If the answer is good, fantastic. If the answer is not, then we'll get someone to manually answer, and we'll improve our documentation to answer that better in the future. We've also been using GPT-4 for image labeling or in evaluation. In Pinterest, we have about 50 different machine learning use cases, and we have to label a lot of data to be able to categorize images correctly. So one of the things we did was we actually generated text description for every image, and then from the text description we could categorize. Is this a safe image to show on Pinterest or not? And there are many different categories. And so we spend about $12 million a year just on labeling, and it takes a long time to go and get people to label data. With ChatGPT, GPT-4, we were able to, of course, have almost instant answers, and that can reduce our cost probably by about 10 million. We also, I mentioned, can migrate code faster. We can document tables. We have a Copilot for analytics, and we did text to SQL as well. And this is just a little demo of actually our Slack Q&A. You ask it a question, and it'll give the answer straight away. And then you can say, it looks good to me, or reject this. OK, so what's next for us? So for data analytics, actually, the biggest challenge is changing the culture. So we've gone from no governance at all, lots of silos, and we need to bring this together. And so we're doing a lot of training of people to get them to understand how important it is to have high-quality data. And for developer productivity, there's always the laggards that don't want to adopt something until really late. And so encouraging everyone to use GitHub Copilot and giving them time to do that has been really important. And the other thing we do is we try out lots of new ideas. We often do hackathons. We have hundreds of different ideas, and we just see which ones work, which ones don't work, and then ones that do work, we'll roll it out to production. So thank you.
Thank you, Dave. I'm really glad you didn't say that you improved developer productivity by just cracking the whip and just making people work harder.
No.
Okay, good. Okay, we do have time for questions. Unfortunately, I think the Slido is not working, probably because our Wi-Fi is bad here, but we can take questions from the audience. And last time I felt bad because I didn't let anybody in the back ask a question. So is there anybody in the back that has a question? I see a gentleman here in the back row of the seats. They're bringing a mic.
Hello.
Hi.
So my question is more from an organizational alignment standpoint. Like, you consolidated tables, you created these data stewards who own this.
Yep.
Now, I have seen that there is this data engineering organization and the business organization who owns. So 2 questions. One, is the business organization part of the data engineering group, or is it separate? That's the first question. Second, where these data stewards are they part of data engineering or business?
OK, great answer. So within Pinterest, everyone uses data, and everyone creates data. And so data engineering is really about the systems, the platforms, enabling everyone to be more productive. We do own some of the data, but by and large, we want all the different business units to be able to own their own data. So the data stewards, we have some data stewards are from data engineering. Is basically they're very well versed in doing database designs, schema designs, but they work with the data stewards that are in each one of the domains. And the domain owners are embedded within the teams that are actually generating the data and using the data. So that's how we organize. We do have a business intelligence team within data engineering as well, but that team is really to create the tables that make people more efficient and more effective.
All right, any questions? We have one here at the front. I have a mic here.
Thanks so much. I just wanted to ask you, with Copilot, what are some safeguards that you use so that developers don't just take the code that Copilot generates into production?
Yep.
And that you check it and that you make sure it's safe and that, yeah.
Great question. So we actually did some analysis on this because what you're asking is really important. You want to make sure the quality is high. You don't introduce security problems and the like. And so we, in Pinterest, the way that we develop is actually we almost go from development straight to production. There's a bit of QA, a little bit very lightweight, but straight to production. And we measure things like the number of security incidents, the number of incidents that are caused by bugs. And what happened was that there wasn't much change at all. In fact, it was slightly improved from before. So, and this is across many, many thousands of check-ins. So that's how we measure them.
All right. Do we have anybody here on this side? Maybe I see a gentleman right here, blue shirt, I think.
Thank you. And I'm very intrigued by overall presentation, but more specifically, the ability of ChatGPT to document your tables. Could you share a little more? What was the prompt? Because it only can, now Turbo can take only 300 page textbooks, right?
Yeah. So that's a excellent question, insightful question, because how you do prompt engineering is really important. Setting the context for GPT-4 and GPT-3 of what they need to do in order to give a good result requires some trial and error. We probably could publish what our prompt was so that it would make it easier for others, and that's something that I'll ask the team to do. But yeah, for actually documenting an individual table, you don't need to actually pass that much data across. So you just pass the schema with a few extra descriptions to it. But we also pass some queries of how that table was queried in the past, so that to give ChatGPT some more context. When it comes to figuring out like which table to use out of the hundreds of tables to use, we've basically, when we're doing search, for example, or doing text to SQL, we have created descriptions for each one of these tables, and then the amount of text for the descriptions is not that large, and so it can hold pretty much all of that when we send it through a prompt.
All right, I think we had one question here.
Yeah, how do you measure the developer productivity? I mean, you say 1x to 2x, so what's the metric that you're using to measure that? And
Yep. So, I mean, the ultimate metric is impact and how many projects are completed. So what's the end result? But there are some measures that you can have that give you an indication of how things are going. So things like the number of commits per month over a population of like 1,600 or more engineers. You can see what the averages are over time. And we've tracked it over time, over the years, as the engineering team has got larger, the number of commits per month has gone down. And then we've actually seen, as we've introduced Copilot and some other things, that it's gone back up. The other one is the sentiment score. How do people feel? You know, are they motivated? Do they have a lot of blockers to get them into production? And so we measure things like what's the build speed? What's the time to go from build to deployment? How long does it take to do an experiment in production? And we bring all these times down so that it makes people far more productive, and we measure the sentiment score of how do people feel. And then they give us feedback on where they feel blocked and where things are not good, and we go and fix those.
Okay. Is there anybody on this side? I've been neglecting this side. Any questions over
They're
here?
all basking in the sun.
Anybody in the middle? How about here? Oh, can we reach? Thanks.
Thank you. I was more interested in the Slack app that you created, and
Yep.
just maybe if you can give an overview of the tools you used to create that Slack integration.
Yep. So creating a Slack app is not that difficult, but it really just required a call to GPT-4. And so what we would do is we'd actually take our documentation. Our documentation is mostly in a wiki, but for design and requirements documentation, it's in kind of Google Docs. And so what we basically do is scrape that documentation and then feed it into the prompt with ChatGPT with the question, and then get the answer back, and then just display the answer. So not that complex, but the trick really is figuring out whether you've got good answers or not, and improving that over time. And so we've had a really big push to improve our documentation, update it. We had a lot of old docs lying around, so that gave us a really good incentive. And the teams are an incentive as well, because they want to reduce the amount of time they're having to do support, so they can do some engineering work themselves.
That was all we had time for the questions, but I am going to ask you, and I'm very curious to hear your answer, what do you enjoy so much that you completely lose track of time? Writing Slack apps?
That could be one thing, but what I really enjoy is I love learning. And so I'm very fortunate. I've got 20-odd teams, and I read just about every single design doc that's written. And so I learn a lot about the technologies that have been used, why they're being used, understanding the requirements of each team. And so I get a lot of satisfaction from that. I can just lose myself in time doing that.
Amazing. All right. Well, thank you for joining us.
And
Really
there's another session, I think, in a room maybe 1 o'clock. I need to check the time.
Oh, the round table?
To talk about developer productivity if anyone
Excellent.
has other questions.
All right. Thank you very much. We'll see you guys back here in 10 minutes.